Hey again. So, if you remember how to add, subtract, multiply, divide, and solve proportion questions with fractions, you probably don't need to watch this video. But if you want to watch it, I will go through this real quick for you. So, when adding fractions, remember you must find the common denominator first. So, my quick strategy for you is to find a common denominator. Remember, there's more than one. We can just multiply the two existing denominators together. There's other ways to do it. You can use what's called the least common multiple, but you don't have to do that. Is the nice thing. You can just like for example, this first one, pick the common denominator to be 4 times 5, 10 times 7, and 2 times 4. Right? You could, for that last one, pick the common denominator to be 4, and you could probably solve that question pretty fast. But you don't have to do it that way, because that involves knowing how to find the LCM, right? And we'll go over how to do that, but you don't have to do that, so we just shouldn't worry about it, right? So the first step is, let's write this a little bit better. So we have our two existing fractions, right? But we want to multiply them. Remember, we can't just multiply them by whatever we want, because that would, of course, change the value of the expression. So instead, we need to think, okay, how can I change the denominator without changing the size of the fraction? Well, you can just multiply it by 1, but in a clever way, right? Multiply this one by 4 over 4. So what does this accomplish? Well, remember we multiply across for multiplying fractions. So with just that one simple step of multiplying by what it doesn't have, we now have a common denominator of 20, and we can add those fractions across, and then it becomes super easy, and then we have the answer. Okay? Let's do it again. 3 over 10, 3 over 7. We have to adjust both of them before we can add them together. What do you adjust by? Well, we want to make the denominator 70, so this ought to be a 7. This ought to be a 10. Multiply across, add them up, 51 over 70. Okay? Same thing, 1/2. The minus sign doesn't really change much. Process is still the same. If we choose that we want the common denominator to be 8, this one's got to be a 4, this one's got to be a 2. You can probably see the pattern, right? You're multiplying by the other denominator. And you can do it like this every time, which is really nice. Whereas LCM, you have to really think about it. Like, if I told you to do this, that might take you a while to figure out what that LCM is. But the shortcut, which, yes, isn't the best way to do it all the time, but just multiply them together and just don't think about it. We don't need to, we're in high school now. We don't need to know how to do fractions like this on paper. We really don't. This is a review. Multiply across, get that -2, which of course is minus a fourth. Let's look at another way to do this one, but completely visual, just for fun. So if I have a pizza, and I have half of it, so let's shade that in blue. So you have half the pizza left, or let's phrase it this way. You have half the pizza left in the box, but you figure out that you're going to need to eat 3/4 of a pizza, because maybe you have 3 friends and you all want a quarter. So you got to somehow subtract this much of the pizza. So we'll put a little minus sign in there. So just with that picture, it's incredibly hard to say what the answer should be. I mean, one could say the answer is 0, because you have 1 piece minus 1 piece, right? Of course the answer isn't 0, but like, this is really confusing, right? Because, well, you could also draw the picture like that, right? Well, now we have 1 piece minus 3 piece. Shouldn't that be 2 piece? So the answer 2 minus 2, right? It's really confusing. So what you have to do is cut that pizza so that they're cut the same way, and then subtract them. Minus 1/4 pizza. 2/4 minus 3/4. Well, you're missing 1/4. So you can add fractions like that too. But this one here you probably couldn't do that because it's hard to draw 10 cuts on a pizza. But if you had a computer and you can draw a picture of this, it would be helpful. So think of adding fractions or think of finding a common denominator as finding out how to cut the pizzas so that they all have the same number of slices. Because if they don't have the same number of slices, you can't really talk about parts and wholes anymore because it's just too confusing. Okay? So I'll write that down. Finding the common denominator is like cutting a pizza, cutting the two pizzas because we have two fractions, so that ST both are cut the same. The same arrangement. Okay. Let's move on to multiplying fractions. I'm actually not going to fill in the blanks here. I mean, we should know that you just multiply across, right? And then when we divide, we flip the second and multiply across. And I guess while we're here, I should tell you, why, right? Everyone says this, but no one really dares to explain why. The process is nice and easy, right? Just flip it and multiply. And of course, remember to change that sign to a multiplication, not division. But yeah, I showed this in class, right? So if you have 1/2 divided by 4/5, and you wanted to try and simplify that to just be one fraction, well, you gotta somehow get that fraction, because we have a fraction and a fraction. So the strategy would be to make it so that the bottom becomes 1. Look at that, look how nice that is. Right? And you're not supposed to know how to do that. Like someone else came up with this. It wasn't even my idea, right? Whoever came up with the idea of how to add fractions and divide fractions and all that came up with this. But look, this is the same thing as this. Look at that beautiful little proof that we just did. We just showed that when you divide a fraction, you flip the second and multiply. Okay. Finally, proportions are the ones with the equal sign, right? You can see all those examples there. So two fractions, what we're going to work on today is just cross-multiplying. So notice that we've moved from simplifying an expression to solving an equation. So the work is going to look a lot different because we're actually going to box in an answer that says x equals something, right? Let's start with this middle one here. So cross multiply, remember, if you have this, you circle the cross, and then you just multiply. You would do 5 times 50 and 2 times x. Right? Also seems like magic, right? But it's really not. It's just a shortcut. But it does get the job done, doesn't it? Because we can figure out pretty fast that x is 125. But, don't think it's magic, right? Look at it this way. So this one, you could just do the same exact thing. But what if we just multiply both sides by 4 and take it slow? And then we choose to multiply both sides times 5. Because we're trying to clear denominators, because we don't like fractions in these problems. Okay, we just cross-multiplied though, didn't we, right? Right? Boom, boom. So all we're doing, it's just cross-multiplying, is just multiplying by both sides by both denominators in separate steps. But of course, the cross-multiplying makes it one step. But we shouldn't lose the fact that all we're doing is just multiplying both sides of the equation by a number, right? It's not like cross-multiplying is a very basic thing, but in school, we're so encouraged to do the thing, and then just do the answer. But couldn't we just do this? Wouldn't this help us in the long run if we just did all these steps? We'd be a lot better at solving equations in Algebra 1, right? All right. Just something to think about, right? So let's cross multiply. So I think that's going to be 98, and then we divide. So cross multiplying is, it's real fast, right? Think about this though too, because if we plug that in to check our answer, if you divide this by 7, we get this nice, and it works, right? So that's called a proportion, right? So those two fractions are the same, right? Because we took the top, took the bottom, and then divided them or multiplied them by the same thing, right? So in math, we have a name for that. We call that scaling, right? So you can scale 49 down by a factor of 7 to get 7, right? You scale 14 down by a factor of 7 to get 2. So 49 over 14 is the same as 7 over 2 because the numerator and denominator can be scaled equally by a number, right? So that's all fancy talk for just saying simplifying fractions. So sometimes proportions are no more than just simplifying the fraction. Okay, and then that last one you can try. It's just going to be a decimal. This one too we can write as a decimal since I did ask to write it as a decimal. And then finally, just a final comment about these special fractions here. 0 over 1 is the same thing as 0 over just like 12 or 0 over 100 or even 0 over negative 100. It doesn't matter. They're all equal to 0. And here's why. If I bring in a platter of 0 cookies into my classroom and I have 12 students and I say, all right, everyone's getting a cookie. How many cookies do you have as the student? Well, you're going to have 0 because there's no cookies, right? So that's the part, right? Well, 0 is the total number of cookies that you get. But yeah. So anyways, that's the explanation, right? So 0 divided by a number is completely legal. We'll do this a lot, right? Heck, when you have like something like this, we often divide both sides by 2, right? But sometimes we don't realize that we're doing this, right? So when we do that, we're writing on that paper that x is 0. 0 divided by any nice natural number or anything other than 0 pretty much is 0, right? So we actually do that. You guys knew that without maybe knowing that you knew it. But these bottom two can be completely chaos. So this one just simply doesn't exist. You can't divide by 0. I mean, you can think about dividing by 0, but you just can't do it. That's like if I come with, I have that chocolate bar and I want to divide it into 0 parts. Well, it's like, you might say, oh, well, that means you just keep the chocolate bar the same. Well, no, I still have one chocolate bar if I keep the chocolate bar the same. So this is it's completely bonkers, and we can talk about it more if you're interested. But these two things are more of a calculus idea, especially the bottom one. So this one's got a special name, undefined, which actually just means that I don't know. There's some times where 0 divided by 0 can be 0. But I put like quotes around this because there's other times where 0 divided by 0 can be equal to 6. But this is like it's almost made up, right? We don't divide by 0. We can't do that. So both of these things, what I want you to take away for now is that we cannot divide. In this algebra setting that we're in high school, we cannot divide by 0. And this is going to have applications too when we start working with domain, because we're going to have a function like this. Let's say it's got x minus 3 in the bottom. Well, we're going to talk about what happens when x is 3, right? But you should know in the back of your head that if we plug in x equals 3 into this right here, something bad's going to happen, right? Because we can't divide by 0. So we'll talk about that more when we learn about functions in domain.